Hello, everyone. So today I'm going to be telling you how to do a multiple regression on SPSS. So our data over here. So our two predictor variables for our model are grit and emotional intelligence. And our dependent variable here is life satisfaction. So we are going to look at um, grit and emotional intelligence as predictors of life satisfaction and test whether this model is a good model to predict life satisfaction or not. So we already have our values over here for grit, emotional intelligence, and life satisfaction. You can ignore all the rest of the items that are over here. So what you're going to do is you'll go to analyze, go to regression, and then go to linear. And once you click on it, this window will appear. So you need to put your score on life satisfaction. That is your dependent variable over here. So I click this here to go back so that I can just show you these also. Yes. So score on life satisfaction, I add here in the dependent variable. And grit, I add in the independent variable. And I add emotional intelligence in my independent variable. So since we are doing a normal enter method of regression, we are not doing a hierarchical stepwise regression because we don't know whether grit is a better predictor of life satisfaction or whether emotional intelligence is a better predictor. So we are going to put both of them together in the model and then test it. So then you're going to go to statistics. Statistics, you should select the estimates, the confidence intervals, and the model fit. R square changed, you will need if you're doing a hierarchical regression. So you don't need this for enter method. Descriptives, part and partial correlations, collinearity diagnostics. Then you click on the Durbin-Watson and the case-wise diagnostics. And you click continue. Then you move to plots. Plots, you're going to put the Z score of the residuals on the y-axis. And you're going to put Z prediction on the x-axis. Right? And you're going to also click on this histogram and normal probability plot over here. And you click on continue. Then you go to the save option. So when you go to the save option, you have an option of getting to know what are the residuals for each of the responses, participant responses that you've got, and to look at what are the influence statistics and the distances. So this I'm not going to do for this multiple regression, but if you want to know, you can just go to the save option. And here, if you click on standardized beta, standardized fit, hooks, and leverage values. And if you want the residuals, then you can click on the standardized residuals values. And you click on continue. Then you go to options. You can select what is your level of significance here and what you want to do with the missing values. So here we've ticked that you want to exclude cases which are pairwise. You can also choose to replace them with a mean. And you click on continue. And then we click on OK. And this is the output that SPSS will provide. Now the next step is how do we interpret this output which SPSS has given us. So first we are going to look at the descriptive statistics. Descriptive statistics will just tell you the mean, the standard deviation, and the total number of participants. So here we have descriptive statistics for all three of our variables. The next we are going to look at the correlation table. Now the correlation table will tell you specifically what are the correlations between each of the variables. So here you can see this is a Pearson correlation. And let's see, first is the score on life satisfaction. So when we look at it over here with grit, the correlation is a positive correlation because there's no negative sign here, right? So there's a positive correlation of 0.273. And with emotional intelligence and life satisfaction, the correlation is again a positive correlation of 0.458. Now, whether this correlation is significant or not, we look at significance over here. And we see that for both of these, the significance is 0.000, which means it's less than 0.001. And that means that that is a significant correlation. So there is a significant correlation between life satisfaction and grit, and there is a significant positive correlation between life satisfaction and emotional intelligence. Now you can also look at what is the correlation between grit and emotional intelligence, and that is 0.595 over here. And that also, according to this table, is significant. Then you move on to okay, the next variables entered or removed. This table just tells you that you use the enter method. That's all. There's nothing else that you need to look at in this table. Next important table is model summary. So you come to this model summary, and this is what's going to tell you what is the. This is what is going to tell you what exactly whether your model was significant or not. So here you're going to get your R. So R is your multiple correlation coefficient, right? So here we have a positive correlation of 0.458, right? And then we're going to look at what is R square. R square is 0.209. So R square is an important number here because that actually tells you the extent to which your predictor variables can predict the variances in your dependent variable. And if you multiply this 0.209 by 100, you get a percentage. So if we multiply this by 100, we get 20.9. So our interpretation for this is going to be that 20.9% of the variance in the scores of life satisfaction can be explained by grit and emotional intelligence. So what is adjusted R square next? This is basically, it sort of takes care of the error. So depending on your number of participants, this will adjust your R square to give you a better estimate and to reduce errors. So our adjusted R square is also almost similar. That's 0.200. So if you convert that into percentage, that will be that 20% of the variation or the variance in the life satisfaction scores of people can be explained by grit and emotional intelligence. Next, you have the standard error of the estimate. And then you have the Durbin-Watson. So what is Durbin-Watson? Durbin-Watson is basically when you're testing that there is no autocorrelation between the residuals, you look at the Durbin-Watson. Now, Durbin-Watson should be as close to 2 as possible. Like, who would say that there is no autocorrelation between the residuals? However, it can range from 1.5 to 2.5, and the closer it is to 2, the better it is. And another thing I wanted to tell you about R is that R is basically the correlation between your observed results and the correlation between your observed results and the results which are predicted by your model. So what the scores that you actually got and what your model thought that you should get based on grit and emotional satisfaction. So that correlation is 0.4. Now we come to the ANOVA. So now we need to determine whether this model itself was significant or not. And for that, we look at the ANOVA table. So here you can see there's an F test which has been done. And the significance here is 0.000. So this is again less than 0.001. So which means that this model is a significant model. Now, just because the model is significant itself does not mean that each of the predictor variables that we have chosen, they will also be significantly predicting life satisfaction. So once we get to know that, okay, whether our model itself is significant or not, then we move on to what are the coefficients. The coefficients will tell you what is the constant. So constant is when you keep the scores of all the other variables 0, then what is your score of life satisfaction? So this is your constant. And you get the score on grit and the emotional intelligence. So it will tell you what are the unstandardized coefficients and the standardized coefficients. And in order to determine whether each of these predictors is actually significant or not, there's a t-test which is done. So here is your t-test results and the significance. So you can see here that for the grit, the significance is 0.997. So that is way above our level of significance, which means that grit is not actually a statistically significant predictor of life satisfaction. But when you look at emotional intelligence significance is 0.000. So here we know that this is less than 0.001. So this is a significant predictor. So what do we get to know from both of these tables, or three of these tables actually, is that our model of predicting life satisfaction with grit and emotional intelligence is a significant model. However, only emotional intelligence is a significant predictor of life satisfaction, and grit is not. So in this table, you can also look at, you will get what are the confidence intervals and what are the correlations and what is the collinearity statistics. Now, collinearity statistics is important because you don't want multicollinearity in your model between your variables. So multicollinearity is that the predictor variables themselves are so correlated with each other that it's difficult to differentiate between the two of what is having how much impact on the dependent variable altogether. So for this, you can first, in order to check this, you can first look at what is the correlation between your predictor variables. So this, what we looked at before was 0.595 is the correlation between grit and emotional intelligence. So that is a moderate level correlation. And we look at our tolerance values and our VIF values. So VIF is variance inflation factor. So you always want your tolerance values to be definitely above 0.2, but the higher it is, the better. So here we have a decent number, 0.646 for both of our variables. And tolerance is inversely related to the VIF. So VIF should always be low. Like it should definitely be lesser than 2 or 3, right? So if your VIF is so high that it's approaching 10, then there is a huge issue of multiple. So you need to check these two levels, tolerance and VIF, to ensure that there is no multicollinearity. Then you don't need to look at the collinearity diagnostics. It's enough if you look at the tolerance and VIF. The residual statistics, this will tell you what are the residuals. So now you need to ensure that there's no outliers in your data. So this will tell you what is your minimum and what is your maximum residue. So you look at the standardized residual. Standardized residual should be between -3 to +3. So definitely if you have anything above than 3, those are the outliers in your data. Those responses are outliers in your data, and they should be removed in order for you to improve the predictability of your model, because you're trying to generalize your model, right? You're not looking at exceptionally high EQ people. So here our standard residual is between -2.433 to 2.063. So which is fine. There are no outliers over here. Next, we look at the charts that we had asked for. So one of the assumptions for multiple regression is that there should be a normal distribution of residuals. So these two graphs that are there, they help you find out whether the residuals are normally distributed or not. So you can see it says regression standardized residual. Right? So this is also fine. Almost a normal curve. There is a little bit higher number at -1, but I think this is acceptable. Then you can also look at the normal PP plot of regression standardized residue. So here, this again, you can see that this is a straight line almost, a little bit here and there, but it's not going to be perfect. If it was perfect, then the model itself would have been, great. So here, we've already checked that the residuals are normally distributed. And you can also look at the scatter plot to see what is the relationship between your residuals, observed residuals and the predicted residuals. So there should not be any sort of a relationship between them, right? No sort of correlation between the residuals themselves. So the scatter plot also helps us tell that there is no relationship here. So for example, if these points over here, all the way they were moving from here till there, in a sort of a line, then we would have known, okay, yeah, there is some sort of relation. But here it's like mostly evenly distributed on the right side, left side, top and bottom. So that helps us see that there is no correlation between the residuals. There's no other correlation. So these are your results. And ultimately, when you want to summarize your results, you can refer to that the model, the multiple regression model with these predictors was statistically significant. However, only emotional intelligence was a significant predictor and not grit. Right? And you can give all your statistics in the form of a table when you're reporting your results. So you can show your R square, adjusted R square. For the assumptions, you can show your Durbin-Watson, the graphs at the end, the tolerance and VIF levels. In the main table, you can show what is the unstandardized coefficients, standardized coefficients, and the significance results of the t-test for your predictor variables, and your confidence intervals. So, yeah, that's it. Thank you for listening. If you have any questions still, you can just drop them in the comments below and I will try to respond to them. And thank you. Have a great day.